bit some data is there. Bringing some fluid mechanics with this ray optics. That's all. Nothing is there. Go back to first fluid dynamics. I think at t equal to 200 seconds, we should know what is the level of water and with what speed the level of water is moving. The insect anyway, it has to move with a constant speed. So what is needed at t equal to 200 seconds? What is the level of water in the tank and at what speed the level is falling? Work out, I think some calculations are needed. Let me proceed. This is a silvered mirror. This is a level. Okay, the inset is somewhere here. Let's get into. So this is at t equals 0. 80 meter. This h is equal to 80 meter. This 80 meter is what I'll call h. This is at t equals 0. At any time t, let this be the situation. And the level of water, let it be h, here velocity v. So I think what are the equations? If you can remember the time taken for the level to become from h to h, if you know the formula of fluid dynamics, directly write the formula and you can save time, or else you have to derive. I'm telling this one, see, advantage you have, always student has to come with a minimum memory. There is a minimum memory is needed. What is the minimum memory? The standard derivations, the standard topics, the standard numericals, all this should be the part of memory. See, the requirement of this particular thing is like you should know time taken for the level of the liquid at any time. If h is the level of liquid, what is the time taken? If you know that t in terms of small h, capital A and small a naught, or very easy, no, this problem. So or else you have to go back to the thing what all you have learned. Still many of you are having egoism that okay, I can manage. First of all, come out of that egoism that okay, you are a good thinker. There's no doubt with a good thinking. What about the hard work? 0 to t, initial level is h, this small h, this is a negative sign. Even for anybody, even for me also, it takes so much of time to derive these things. You see that one. If somewhere by chance you are wrong here, gone, no, though you know this question, lack of memory, you lost these two questions. minus 1 by 2 plus 1. Okay, 1 by root h, sorry. Into time. So this will become 2 root h minus h a naught a root 2 g, or the expression for t will be a naught. Okay, this will be a by a naught. A naught is area of cross section of hole. Will be root 2g. Okay, now you got the time, substitute that here, and you'll get the level of the liquid. Substituting all this, you'll get the level of liquid. Then somewhere at that instant where the and at t equals 0 is at 81 meter from the base. Filled up to height h is this one, is at 81 meter. How much of distance, at what depth, what height the insect will be there, we'll calculate velocity of insect into time. At that instant where the insect will be, all will get information. Somewhere here we'll see the insect. Okay, this we need at what height it is. There's the position of insect. With what speed the level is decreasing, even the liquid also, this needed know how to get this VL. This VL is what you are going to bring it from here. So this VL is nothing but dH by dt, which is equal to A naught by A. I think there's the first problem you have come across of like this. How to calculate the velocity of the level of the rate at which the level of liquid is falling. Negative sign means decreasing, that's all. Don't bother negative sign. We have everything. Now, what is y? The displacement of there's only the displacement, no? Displacement of insect. And then the position y will become 81 minus SI. Why your teacher is writing like this? Because initially the insect will be at a distance of 81 meter. Then finally, what is the distance it has covered? VIT. It has moved some distance. So at what distance from the bottom of container it should be then? 81 minus SI. Okay, this will be the position of the liquid or the insect here. Velocity of insect 2 centimeter per second. The time is what you calculate. That has to be substituted. You'll know velocity of insect. How much it is? 2 centimeter per second. Okay, we got everything now. Now, the velocity of image of insect as observed by the insect at again, what is this everything now? So this is a mirror, no? Below there is a mirror is there. Come for this. I think you have to go back to the at what distance the image will appear for it. So if you are getting confusion, you bring the diagram like this. This is the level of water. there's the water, and somewhere here is what? The insect. Here the insect is at a height liquid level is decreasing, VL, insect is moving with a velocity VI. This is at t equal to 0. So first this mirror will see this insect somewhere here, no? So I'll call this as object O now. The insect as object O. Now it will appear at O dash. Just now previous problem what we discussed, that has to be applied here. So along this line, put it here. So where it will appear? It will appear at O dash. So what is that O dash? It will be equal to y minus. So what is this distance will be? Mu into, it will appear mu times, no? At what height the insect is from the level, top surface of the level, y minus h. So it will appear mu times of that one for the mirror. Now the mirror will form its image. Where do it will form its image? It will form inside this one. This will be I dash, will call it. So what is this distance will be? H plus mu into y minus h. Okay, now again this I dash, again it will undergo refraction. So there's everything from here, everything will appear inside the water. So the final image should appear here, I. So that height, how to calculate this one? This is what? HF I'll call it. What is HF? HF should be equal to only HF will calculate first, will be H plus so for the image it will appear at a distance of the velocity of this one, no? Y minus h plus HF. Now what you are going to do is asking velocity of image of insect as observed by the insect at t equal to 200 seconds. Shall we go for differentiating this? What do you mean by dot? Derivative of that one. What shall I write y? Increasing or decreasing? The level decreases should be negative, no? The velocity of image only it should be taken. Velocity of image given, no? 2 centimeter per second. H is VL. Okay, this will be minus VI. We'll substitute always sign. This will be minus VL. Again H is minus VL by mu. So this is the now what is it in? The velocity of insect as observed by the insect at t equal to velocity of insect as observed by the insect at t equal to 200 seconds. So what you should do here now, you have to substitute calculations. I think everything will come from calculation. I brought everything on the screen. Make observation. Yeah, we'll proceed here now. It'll be like this. So first, if you can get this P, rest all everything will become very easy for you. Okay, sorry, T is no, H is needed. Only H is needed, you see that one. But is asking the velocity of image of insect as observed by this one. So for that we should know what is like velocity of insect. We know velocity of the liquid. For that we need H. That H is what? From T we'll get it. What is T? T equal to 200 seconds. Substitute that, you'll get H. Substitute here, then you can manage here. No need of calculation of all these things. Huh? Our discussion should be from here. H is needed. If you can get H, and you can see that one. This you can save time. That's what I mean to say, like a time taken to empty the tank. No, this you have to save time. If you can remember this, you can proceed from here. I think you have to work out calculations. I'm just sharing only the ideas. After there's the next part. After certain time, velocity of image. Look at the second question. I want students to really answer this. Anybody wants to give explanation why velocity of image will remain constant? This will our answer will come 6 centimeter if you solve this. Okay, no. After this, okay, fine, very good. So once the old tank will get empty, no, then the velocity of insect will remain constant, no. After a certain time, velocity of image of insect becomes constant. The time at which this happens. So time taken for the old tank to become empty. What should be the limit now? 0, no. It should be small h should be 0. When the tank becomes empty, then the velocity of image will constant. There is no any other concept. Don't get. So here, so we'll write that instruction. Next question. When tank becomes empty, velocity of image of insect becomes constant. So what is that time? That time you can calculate h. Here we have equation root h a by a naught. And the answer will be this one. Okay, you can encounter questions of mixed with fluid dynamics. You have to be ready with all these. Mains not possible. I am talking about the advanced. Main such like question by the loss.